Have you ever wondered how big the universe really is? It's a question that has fueled human curiosity for millennia. When we talk about the size of the universe, we aren't just referring to the stars, galaxies, and cosmic dust that we can see. No, the universe is much more than that. It encompasses everything that exists, whether we can perceive it or not. It's the entirety of space, filled with galaxies beyond number, stars beyond count, and an expanse of cosmic dust and dark matter that stretches to infinity. It's all the matter that makes up these celestial bodies, from the smallest atom to the largest galaxy cluster. It's all the energy, from the faintest photon of light to the most powerful gamma-ray burst. And it's also time itself, the fourth dimension that intertwines with space to create the fabric of our reality. So, how do we even begin to comprehend the scale of the universe? You've heard of the observable universe, right? But what does that mean? Well, let's break it down. The observable universe is essentially the part of the universe that we can technically see from our home planet, Earth. We can't see everything in the universe because there's a cosmic speed limit set by light itself. Light travels at a mind-boggling speed of approximately 186,000 miles per second. To give you some perspective, if you could travel at the speed of light, you could zip around Earth's equator about 7.5 times in just 1 second. But here's the catch. Even at this incredible speed, light takes time to reach us. The light we see from our sun is about 8 minutes old by the time it reaches Earth. So we're always seeing the sun as it was 8 minutes ago. Now extend this concept to the rest of the universe. The further away an object is, the longer its light takes to reach us. Therefore, when we look at distant galaxies, we're not seeing them as they are now, but as they were billions of years ago. We're literally looking back in time. So, the observable universe is not just about space, but time as well. It's the ultimate cosmic history book, telling us stories of the universe as they unfolded billions of years ago. Now let's dive into the numbers that will truly boggle your mind. Ready for some astronomical figures? Let's delve into the size of the observable universe. To truly grasp the enormity of the cosmos, we must first understand the concept of a light year. It's not a measure of time, but of distance. The distance that light, the fastest thing in the universe, can travel in a single year. This is a whopping nearly 6 trillion miles. When we gaze up at the stars, we're actually seeing light that started its journey years, centuries, even millennia ago. Now imagine a sphere whose radius is the distance light can travel in about 46.5 billion years. This encompasses what we call the observable universe, the part of the cosmos that we can detect from our vantage point here on Earth. It's estimated to be about 93 billion light-years in diameter. But how can this be, you might ask, if the universe is only about 13.8 billion years old? Shouldn't the radius of the observable universe be 13.8 billion light-years? Here's where it gets even more mind-boggling. The universe has been expanding since its birth in the Big Bang. So light emitted by a galaxy, when the universe was just 1 billion years old, for instance, has traveled 13.8 billion light-years to reach us. But during that time, the galaxy itself has moved, carried away by the expansion of the universe. It's now about 46.5 billion light-years away. So the observable universe is a sphere of space-time with us at the center, spanning a staggering 93 billion light-years in diameter. That's a number so large it's almost impossible to comprehend. It's like trying to count every grain of sand on every beach on Earth, and then multiplying that by 100. Amazing, right? But wait, there's more. What lies beyond the observable universe? That's the big question. A question that has been on the minds of scientists, astronomers, and philosophers for centuries. Let's delve into some of the theories that attempt to answer this question. First, there's the multiverse theory. This suggests that our universe may be just one of an infinite number of universes, each with its own laws of physics. Picture it as a cosmic bubble bath, with each bubble representing a different universe. Some may be similar to ours, others entirely alien. We could have countless cosmic neighbors, but the vast distance between these universes means they're beyond our observational reach. Then, there's the concept of an infinite universe. This theory posits that the universe isn't just incredibly large, but also infinitely so. It continues endlessly with no boundaries or edges. This would mean that the observable universe, the 13.8 billion light-years we can see, is just a tiny, tiny fraction of the entirety. However, it's important to remember that these are just theories. They're grounded in mathematical models and scientific understanding, but without empirical evidence, they remain speculative. As we push the boundaries of technology and knowledge, who knows what we might discover? We may never know the full extent of the universe, but isn't it fascinating to ponder? It's a thought that humbles us, reminding us of our small place in the grand scheme of things, and yet, it also fills us with awe and wonder at the possibilities that lie beyond our current understanding. So, how big is the universe? The answer is, we don't really know. But we do know that the universe is a vast, mind-boggling expanse of everything that exists. It's so enormous that we can't even grasp its full size. We can only see a fraction of it from our little corner on Earth, our observable universe. Imagine standing on a beach, looking out at the sea. The horizon is as far as you can see, but you know the ocean continues beyond that. That's kind of how it is with the universe. Our observable universe is just the horizon. There's so much more beyond what we can see. And here's the kicker. There could be multiple universes, each with its own laws of physics. Each a separate bubble in an infinite cosmic sea. It's a concept that's as fascinating as it is humbling. In the grand scheme of things, we're just a tiny speck in the vast expanse of the universe.